we are given a motor provides a torque, right? And this motor is providing a torque, and this is, we're looking at shaft A. You see this shaft A. So the torque is being, read the problem carefully. The motor provides, in the double reduction gear train shown, shaft A is driven by a motor attached by a flexing coupling attached to the overhang. So it's attached right here at the overhang. So there is this input torque that is used to drive this gear, and which is driving the bigger gear attached to the other shaft. But we're primarily looking at shaft A. So I know that my input torque starts at the overhang and ends at this center line where I have my gear. So my torque is only present in this area. If you go beyond that, there is no torque, but there is still some bending moment. So as soon as you draw your bending moment diagram, knowing, of course, the forces, so you can calculate the forces, you can find where the critical bending moment is going to be. And if the moment is too small in this area, and you know that you don't have any torques applied, then you may focus on this area only where the torque is present.
So are we designing the type of, like, are we going to pick shoulder fillet? Are we going to pick end mill key seat? Or, because I don't think it's, is it specified in the problem that we have to use a specific?
Correct. Okay. Thank you for mentioning that. That's why in the homework I gave you a proposed design, and all what the comment, like, I don't, instead of having you, each one of you come up with a geometric layout, I already gave you a geometric layout. The one thing I don't want you to use, I don't want you to use any of these diameters. So forget about these numbers for the diameters. I want you to solve for all of these diameters. So this is what you're going to be solving for. So you know that there is going to be a step right here. You know there is going to be a step right here. You know that there is going to be a key here, right? And you know that there's going to be another step here. So you know some of these, and these are the ones I want you to take into consideration. So let's say you find that this is a critical section. And what I'm referring here is the location of the bearing. So I'm looking at B, right? So at B, there is this diameter that they use as 1.574. I'm going to call this lowercase d. And then I'm going to have an uppercase d. And I'm going to say that, oh, this is going through a step. And because I'm using a bearing, if I want this to be leaning on the step, I may want to use a sharp shoulder fillet. So then this will lead me to use the 2.7 and the 2.2 when I am designing or looking to calculate the diameter lowercase d here instead of the 1.574. Does that make sense?
Yes, thank you.
Good, good. And again, I think luckily this problem is not as lengthy as the example because of the fact that the critical sections are kind of obvious. So you know like where you're heading, and then you may just carry over until you go back to the other bearing. But I'm really expecting you to come up with these numbers. And it's okay to have some of them the same.